So we're here at the example table, and in this video we're going to sketch the graph of 3 sine of 2x minus 1. So as usual, we're going to start with something simple, namely just sine of x. So the graph of sine of x is this oscillating curve. Now notice when I'm going to sketch the sine, I'm actually going to start just by drawing the x-axis, and then I'm going to draw the sine curve. I'm going to put the y-axis in later, so I don't need to worry about hitting that point. And actually, if I had really been careful, I would have put these dotted lines in even before drawing the curve. So these dotted lines, it's 1 and negative 1, right? Sine values are only between negative 1 and 1. So this line on the bottom is y equals negative 1. The line on the top is y equals 1. This point here is x equals pi, so let's put a pi in there. And this one here is 2 pi. And likewise, on this side we have negative pi and negative 2 pi. All right, so this is the graph of sine. The first thing let's do is put this 2 in. So when you multiply multiplying the x on the inside of a function, that's going to change the scale along the x-axis. Right? So it's either going to stretch it or contract it. Unlike multiplying on the outside, as we do with this 3 here, which we'll get to, multiplying on the outside stretches along the y-axis. So let's think about what this 2 is doing. We know that sine x makes one complete cycle between 0 and 2 pi. If we multiply x by 2, then everything happens twice as fast. So the sine function is going to make one complete cycle between 0 and pi. So this multiplication by 2 is going to squish everything toward the origin. So let's draw something here. And again, this is just a sketch. So our scale might look very similar to this, but the labels are going to be crucial. Right? That's usually the case when you sketch things. You want to make sure that your labels indicate what's going on. So again, let's start with the x-axis. Let me think ahead and draw these guys here. You don't always need these, but in a case like this where you're shifting and scaling and all this stuff, it helps to have these. So let's draw sine curve. You know, it looks almost exactly the same as this one, but that's okay. So this is still y equals 1. This is still y equals negative 1. Let's throw in a y-axis. Now remember, everything that happened between 0 and 2 pi is now going to happen between 0 and pi. So this whole thing that I've drawn here on the right-hand side goes through only up to pi. So this guy here is pi. This here is now pi over 2, right? Halfway between 0, pi over 2, pi. Likewise, on the other side, should be a mirror image. We have negative pi over 2, and then all the way on the left, negative pi. Now we want to add the 3. And as I said before, if you add the 3 out here, right, we want to put this guy right here. That's going to scale the y-axis. It's going to shift, it's going to expand it or contract it. And since it's 3, it's greater than 1, it's going to expand it. So let's do that on a fresh sheet of paper. So 3 sine 2x. Once again, our sketch is going to look very similar. Start with the x-axis. Draw some dotted lines. Oh, well, mostly dotted anyway. There we go. And now let's sketch our sine curve. Throw in a y-axis. We'll label stuff on the x-axis. That hasn't changed. So this point here is pi over 2. This point here is pi. This point, negative pi over 2, and this point, negative pi. So since we've multiplied by 3, all we've changed is the scale on the y-axis. So up here, we have y equals 3. And down here, we have y equals negative 3. So again, same picture. All these pictures are roughly the same size and everything. What's changing are these labels. That's telling the whole story for us. Now the last step. We want to take what we have before, 3 sine 2x, and subtract 1. This is going to be the only one that looks substantially different, because now this minus 1 is going to take this whole graph and shift it down by 1. So let's draw, now we have an extra horizontal line to draw, in fact. If we draw the x-axis here, well, before, the sine was somehow vertically centered around the x-axis. If we're shifting down by 1, it's now going to be vertically centered around the line y equals negative 1. So these two dotted lines that were at y equals 3 and y equals negative 3 are also shifted down. So we have something up here at y equals 2. This one is y equals negative 1. And then we've got another one down here at y equals negative 4. Right? We took this, y equals negative 3, shifted it down by 1. So now we can sketch the sine curve using this line here, y equals negative 1, instead of the x-axis. So we'll go like this, and like this. Let's throw in a y-axis. Now we want the y-axis to pass through this point. All right? And the only thing left is to label these guys. These haven't changed. This is still pi over 2, but it's now pi over 2 negative 1. Right? It's been shifted down. This one here is going to be pi negative 1. This will be negative pi over 2 negative 1. And finally, this point here will be negative pi negative 1. And that's our graph.